Welcome to A-Level and AP Physics. In today's lesson, we will talk about past paper questions on mechanics from October-November 2020, paper 1. In this lesson, we will talk about questions from different topics. We will talk about questions from forces, momentum, work, and power. And these topics are very important for paper 1. So let's study together. Let's improve together. In the last class, we have discussed from question number 1 to question number 7. And the solution of those questions you can find in mechanics part 01. Today's class we will start from question number 8. For question number 8, it is given to us a device for spraying paint consists of a box with its axis horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. For this question, it is given to us paint is fed into the box. So this one is the box and this one is the tube. So the paint is fed into the box via this tube and the paint is coming out of the box. So this is direction of paint. Paint is coming out. So when the paint is coming out, it means there is a force on the paint. So simply we can say there is force on the paint and this force is by the box. So there is force on paint. There is force on the paint and there is also reaction force on the box. And in this case, action and reaction, these two forces have to be equal in magnitude, but these two forces will be opposite in direction. For this question, it is also given to us the paint is ejected at a speed of 2.5 meters per second, and there are 400 holes in this box. Cross-sectional area of each hole is given, that is equal to 0.4 millimeter square. Density of the paint is also given. We need to find out what is the horizontal force required to hold the device stationary as it ejects the paint. We need to hold this device stationary. So as the paint, imagine that go in this direction, box will go in the opposite direction. So we need to hold box stationary. So we need to apply force in opposite direction of force on box. So in this case, simply we can say the force on box, this is equal in magnitude to force on paint. So these two forces are equal in magnitude but opposite in direction. So when the paint go this way, box will go in opposite direction. We need to hold box stationary. So we need to apply force in direction of paint to hold this one stationary. So simply we need to find out force on paint. Force on paint simply equal to change in momentum. So this is the net force on the paint. That is equal to delta P over delta T. In this case, initial momentum along horizontal was 0. So the final momentum along horizontal also has to be 0. So that's the reason these two forces are equal. Most of the time, many students, they can answer this type of questions because this question is kind of typical question and you will see this one in many past papers. But most of the time, students, they don't get the actual concept behind this question, and that is conservation of momentum. Momentum along horizontal is conserved. So the net force we can find out net force on the paint, and net force on the paint is equal to the force we need to apply on the box to hold it stationary. So that is equal to delta P over delta T. Delta P over delta T, this is equal to delta M times V over delta T. In this case, initial velocity of the paint is 0. So the change in velocity of the paint, that is equal to V. So we can say V times delta M over delta T. Now we need to find out change in mass over time. So change in mass, simply we can write down this is speed and the mass is equal to density times change in volume over time. Change in volume over time. In this case, density of the paint is constant and speed of the paint is also constant. So simply we can take these two quantities out. Then we left with change in volume of paint over over time. Now we need to find out change in volume over time. Imagine that we have one small cylinder, and this cylinder is like a hole. So we are talking about hole. The shape of the hole is like a cylinder, and cross-sectional area of this hole, imagine that is A, and the length of this cylinder is equal to x. Speed of paint is also given. V of the paint is given, that is constant, and that is equal to 2.5 meters per second. We need to find out delta V over delta T. Delta V is the volume, change in volume. That one will be equal to A times X. This is the change in volume over, we have, this is change in time. Now from here simply we can say X over delta T. This is equal to A times V. So delta V over delta T is equal to A times V. So delta V over delta T is equal to A times V. Now we can plug in these values. So we have V here, and delta V over delta T, this is equal to A times V. So simply we can say in this case force on the paint means force on the paint is equal to A times rho times V square. Cross-sectional area is given to us, that is equal to 0.4 millimeter square, means 10 to negative 6. Density is given, that is equal to 900, and the speed of the paint is given, that is 2.5 square of speed. Now if we multiply this one, we can find out force on paint, that will be equal to 0.90 newtons. But one thing we are missing, we have to multiply with 400 as well, because we have 400 holes. So the final answer, if you multiply this one, you will get is equal to 0.90 newtons. So the final answer for this question is B. This is how we can approach this kind of problems. So the resultant force on the paint is equal to rate of change of momentum of paint. Let's move on to question 9. Question 9 is quite simple if your concept is clear. But if your concept is not clear about acceleration, deceleration, and speed, then this question is very tricky one. Let's try to understand first of all what is given to us for this question. For this question, simply it is given to us, we have a balloon. So simply you can imagine that we have this balloon, and we drop this balloon in stationary, in still air, means we cannot ignore effects of air resistance. So you can imagine that these are air particles. So if we look at this one initially, if we look at this balloon initially, if we draw the forces acting on this one, initially there is only one force acting on this, that is equal to mg. So the net force in this case, we can also say net force is equal to mg. Net force is equal to ma, so we can say ma is equal to mg. So from here we can say a is equal to g. So mass is cancelled with this mass. So initially the net force on balloon is downwards, and it has net acceleration downwards, that is equal to g, means a is equal to g. But when this balloon will start moving, there will be air resistance, and air resistance will act upwards. Why air resistance? Because balloon will hit. So imagine that this is balloon and my hand is air particle. Balloon will hit air particle, and air particle will hit back on balloon in opposite direction. So there will be force on balloon in upward direction. So this is air resistance, and here we have weight. As the speed of the balloon will increase, as balloon is accelerating, it simply means that speed of the balloon is increasing. As speed increase, air resistance will also increase. Finally, these two forces, they will balance each other. So we will say W will be equal to FA. So air resistance. So these two forces, they will be balanced. When W is equal to Fa, it simply means that net force on balloon is equal to 0. If net force 0, it means acceleration of balloon will be equal to 0. If acceleration is equal to 0, we call balloon has reached terminal velocity. Terminal velocity. So simply we can say terminal velocity. Or simply you can say balloon has reached maximum constant speed. So we can say constant speed. Now if you look at motion of this balloon balloon is accelerating. Initially balloon is accelerating, but acceleration is decreasing with time, and finally acceleration is equal to 0. Acceleration is decreasing, it does not mean that it is decelerating. So very important point and often misunderstood. If acceleration is decreasing, it doesn't mean that balloon is decelerating. When amount of acceleration is decreasing, it means balloon is still speeding up. Speed of the balloon is still increasing. So we will say balloon still speed up. When acceleration is decreasing, balloon still has acceleration. If balloon has acceleration, it means speed of the balloon is increasing. So it means speed of the balloon is increasing. When acceleration is 0, it means speed of the balloon is constant speed. And these are the points we need to understand to answer this question. Now, if you look at option A, decelerate, not, this is wrong. This is incorrect. So this is incorrect option. Balloon falls at constant speed, incorrect. Balloon accelerate. Decelerate, incorrect. Falls at constant speed, incorrect. The last option, accelerate, then constant speed. And this one is right option. So the answer is D. D is the right answer. Very important concept you need to understand. If acceleration decrease, it doesn't mean that speed is decreasing. It means body is still speeding up, but the rate of increase of speed is decreasing. If we sketch graph for this one, we can see the shape of the graph. If we take V on y-axis and we take T on x-axis. So in this case, acceleration of the balloon is decreasing. It means the gradient of this curve will decrease, and finally it is horizontal. It has reached maximum speed. So this is what is happening, and this one is called VT, terminal velocity. For question number 10, it is given to us an object of mass small m traveling with speed 5u collides with and sticks to an object of mass 5m traveling in the same direction with speed u, as you can see in this figure. We need to calculate the speed, means the combined speed of two objects. So first of all, let's try to sketch this one, what is happening in this case. This is what is happening before collision. So simply we can say this is what is happening before, and now we need to sketch what is happening after they collide, after collision. So after collision, we will see these two objects stick together. So this one is mass m and this one is 5m. We need to calculate the combined speed, means we need to find out value of v. One thing we need to understand, initial momentum is to the right, so the final momentum also will be to the right. So in this case, we need to take one direction as positive. So I will be taking in this case to the right as positive because momentum is to the right. So if we write down momentum before, means the total momentum, or we can say initial momentum, total initial momentum, it has to be equal to total final momentum. We have two bodies, so the first one has mass m and the speed of the first object is 5u, and the speed is positive because it is moving to the right. And if you look at the momentum of the second object, the mass of second object is 5m and the speed of this one is positive because it is moving to the right, and we have taken to the right as positive. Now we need to look at momentum of this object. The total mass of these two objects is m times 5m times v. So if we simplify, this one will be equal to 5mu and this is also equal to 5mu. So here we have 6mv. We need to calculate v. So this is equal to 10mu and this is equal to 6mv. So we can cancel m with m. So v finally, this will be equal to 10 divided by 6 times u, and this is final speed of those two objects. I mean, this is the combined speed of these two objects, and this is what question is asking us to calculate. So the answer for this question is 10 by 6. For question number 11, it is given to us an air bubble is rising through a liquid at a constant speed. The forces on air bubble are upthrust, viscous drag force, and its weight. We need to find out which diagram shows directions and relative sizes of the forces. So first of all, let's try to compare magnitude of forces acting on air bubble. If you look at weight of air bubble. Weight of air bubble will be equal to its mass times g. So simply we can say it is equal to mass of bubble times g. But mass of bubble we can also write down in terms of its density. That will be equal to density of air times volume of air bubble times g. In this case, air bubble is inside the liquid. So here we have liquid and air bubble is inside this liquid. This is telling us that volume of the air bubble is equal to volume of liquid displaced. So we can say volume of liquid displaced. So volume of air bubble is equal to volume of liquid displaced. Now we can write down upthrust. Upthrust is equal to weight of fluid displaced, means weight of liquid displaced. So we can write down weight of liquid displaced. So here we have weight of liquid displaced. And weight of liquid displaced is equal to density of liquid itself. So we can say density of liquid times volume displaced. In this case, volume displaced is equal to volume of bubble times g. Now if we compare these forces, we can say V is the same, G is the same. As density of liquid is much greater than density of air. It means that upthrust is much greater than W. Means U is much greater than W. So this is one thing now we understand. U has to be much greater than W. Now if we look at option 4, this one is wrong, because in this case weight is greater than upthrust. So this one is wrong. This is one thing we can say, this one is wrong. Now next thing we need to understand is direction of forces acting on air bubble. So if we talk about direction of forces, in this case it is given to us that bubble is rising. So bubble is moving up, means the speed of the bubble is up. As speed of bubble is up, weight is acting down. Always weight is acting down. And upthrust, direction of upthrust is always up. So this is direction of upthrust. Now bubble is rising, so drag force has to act downward. So we can say this is drag force. So these are direction of forces. Now if you look at option C is also not possible because W is close to upthrust. So this is also not possible. If we go to option B now, as bubble is moving at constant speed, so it simply means that F net on the bubble is equal to 0. Means upward forces are equal to downward forces. We can say upward net force has to be equal to downward force. Means upward forces are equal to downward forces. So this is not true because the sum of these two is not equal to this. So option B is also not possible. So the best answer for this question is, means the best possible option is A for this question. For question number 12, it is given to us a couple applies a clockwise torque of 9.0 newtons meter to a circular disc. Which diagram shows this couple? If you look at option A, we can calculate torque of a couple. In this case, torque will be equal to one force times the perpendicular distance between two forces. So we have force 9.0, we have to multiply with perpendicular distance. That is equal to 0.5 meters. In this case, value of torque is equal to 4.5 newtons meter. And this one is clockwise. So torque in this case is clockwise. But this is not right option. I mean, this is not correct. Torque has to be equal to 9.0. So this is not possible answer. Now, if we go to option C, for option C, we can also calculate torque. Torque here will be equal to 45 newtons times the perpendicular distance between these two forces, that is equal to 0.10 meter. And this answer is also equal to 4.5 newtons meter. That this torque is, this is the pivot you can imagine. This is counterclockwise, means this is anti-clockwise. So this is also not correct answer. So this is also not possible answer. If we look at option B, in this case we can calculate torque of couple. In this case we have force 45 newtons and the distance between forces is equal to 20 centimeters. It means 0.20. If we multiply this one, our answer will be 9.0 newtons meter. And this torque is clockwise. clockwise. This is what question was asking us to calculate. This is 9.0 and this is clockwise, so this is right answer. If you look at option D, we can also calculate torque due to this couple. Force we have 9.0 and the distance between forces is equal to 1.0 meter. So this is equal to 9.0 Newton meter as well. But if you look at direction of torque in this case is anti-clockwise. So this one is anti-clockwise and this is not right answer. I mean, this is incorrect because torque has to be clockwise. So this is not right answer. So the answer for this question is B. For question number 13, it is given to us a shelf PQ is attached to a vertical wall at P and supports a book. The shelf is held horizontal by a rigid bar XY as shown in figure. So we have shelf. So this one is shelf. It is attached with wall at point P and a book is placed on shelf. There is a rigid bar attached at this point. Weight of the shelf is WS. This is weight of shelf and weight of the book is WB. The bar is at an angle theta to the shelf and exerts a force F on the shelf. The shelf is in equilibrium. So we need to understand what does it mean by equilibrium. Equilibrium means that some of the forces acting on the shelf are equal to 0 and the sum of the torque acting on this shelf is also 0. So these are two basic conditions for equilibrium. Now for this question, we need to find out what are the magnitudes of the horizontal and vertical components of the force of the wall on the shelf at P. Force of the wall on the shelf at P means we need to find out forces acting at this point. Force of the wall means force by this wall on this shelf. We have to find component of that force. Now the best way to answer this question is, first of all, we can draw the line here. So from this point we can draw a line. This is telling us force acting on the shelf, because for this question it is given to us F is the force on the shelf. So F is force on the shelf. So this is the force on shelf. We can say this is force F. This force is the force acting on the shelf by the bar, and this force is given here. In the question it was given to us, and in the question they have drawn this force here. We have simply redrawn this force here to get clear picture of this question. Now we need to find out what is value of this angle. So simply we have to find out value of this angle. If you look at this angle and if I draw horizontal line here, this angle also has to be theta. It simply means that F is making angle theta with horizontal. So this is angle theta and this angle is given in question, or simply you can say alternate angles are equal. Now we can resolve this one into components. So we can resolve into two components. One is horizontal, one is vertical. So horizontal component will be equal to F cosine of theta and vertical component will be F sine of theta. Now we need to look at forces. If you look at along horizontal, there is only one force that is acting on the shelf, and this force is acting to the right. So there must be a force by the wall on the shelf to the left. So there must be a force acting on the shelf by the wall. Then that force we can say Fpx. And that force has to be equal to F cosine of theta, because this shelf is in equilibrium. So forces along horizontal also has to be equal. We know net force along horizontal. So that's the reason we can say Fpx is equal to F cosine theta, but this is in opposite direction. Now we need to look at forces in vertical direction. So we can look at forces in vertical. In vertical, if we look at forces, we have one force F sine of theta that is acting upwards. So we have this force that is acting upwards, and we have WB that is acting down, and we have WS that is also acting down. We need to find out force acting at this point. So this force has to be vertically upwards, and we can say this force is FPY along vertical. So we can write down here FPY. We need to find out this force. So FPY from here we can write write down, this will be equal to WS plus WB minus F sine of theta. So this is value of FPY, magnitude of FPY. Now if you look at given options, horizontal component has to be equal to F cosine theta. So this is horizontal component. So it means option C is not possible. So this is not possible. This is also not possible. So the answer is A. Our answer is B. A is not possible answer because this is telling us F cosine theta. So this is not possible. So the best possible answer for this question is B. So B is the right answer. We can also, when we have find value of F px, we can come back and we can figure out from here, because F minus F cosine theta is not possible. So it has to be F sine theta because we are talking about forces along vertical. So we can find over final answer. Otherwise, you can compare forces like this. Upward forces has to be equal to downward forces, and you can find out FPY. Question number 14. For question number 14, it is given to us a glider is descending at constant speed at an angle of 15 degrees to the horizontal. The diagram shows directions of lift L, a resistance R, and weight acting on the glider. We need to find out which vector triangle could represent the forces acting on the glider. First thing we need to understand constant speed. So constant speed means that F net on this glider is equal to 0. If F net is equal to 0, it means it should form a closed triangle. It should form a closed triangle. So this is first thing we need to understand. If there are forces more than 3, then it should form a closed polygon. In this case, it has to form closed triangle. But if you look at all these options, they form a closed triangle. So this first point is true for all of them. Now the second thing we need to find out, we need to look at direction of forces. If you look at direction of weight, so this is right, that weight is acting down, weight is acting down, weight is acting down, weight is acting down. So this is W. So this one is right. Direction of weight is right. Now if you look at direction of L, so L is acting, you can see from here if we draw this one. So L is inclined to the left. So now if you look at this one, in this case you see this one is L. So this is inclined down. It has to incline this way, but it is inclined down below horizontal. So this one is wrong. So this L is wrong. We will look at R later. So this one is R. We will look at this one later. Now if you look at L here, in this case you can see, so this is L. So this is inclined to the left. So this one is right. Now if you go to option C, in option C you can see L. So this is L. This is inclined to the right. So this one is wrong. Direction is wrong. Now if you look at this one, so this is inclined to the left from vertical. So this one is right. Now the last one we have resistance force. If you look at this one, this value, you can see this is making angle 15 degrees with the horizontal, but this angle is more than 15 degrees. So this one is wrong. So it means option A is not possible. Now if you look at option B, for option B you see it is making angle 15 degrees above horizontal, but this is making angle below horizontal. So this one is wrong. So A is not possible answer, B is also not possible answer. If you look at C, C is not possible answer because direction of L is wrong. If you look at direction of R, this is also wrong. Direction of R is also wrong. So only option we left is D. So D is the right answer. If you look at direction of R, you can see this is making angle above horizontal. So this one is the right answer. So like this, how you can figure out and you can find the right answer. This question is a repeated question. If you check October, November 2014, paper 1-1, question 10, you can find this question there. For question number 15, it is given to us a solid cylinder of density rho c, cross-sectional area A, and length x is submerged in a liquid of density rho L. The upper face of the cylinder is at a depth h, capital H, below the surface of the liquid as shown in figure. The acceleration of free fall is g. We need to find out which expression gives the magnitude magnitude of the upthrust acting on the cylinder. We can find out upthrust using different methods. First of all, let me explain to you upthrust using a straightforward method. Upthrust is equal to weight of fluid displaced. So we can say upthrust on any object is equal to weight of fluid displaced. So we can simply write down weight of fluid displaced. And weight of fluid displaced is equal to density of the fluid. Density of fluid means liquid or gas, time volume displaced means volume of fluid displaced. So we can say FD, volume of fluid displaced, times G. So density of the fluid. Density of the fluid in this case is given, that is equal to rho times L. And volume of fluid displaced is equal to volume of this cylinder. And volume of this cylinder is equal to A times X times G. So we can simply write down upthrust is equal to rho L times A times X times G. So the answer for this question is D. So D is the right answer. But you can also calculate upthrust using a little different method. Upthrust is equal to delta P times A. Delta P time cross-sectional area. So what is delta P? Means the difference in pressure. If we take P1 at this point, let's say we take P2 at this point, liquid pressure. So we can say P2 minus P1, this one will be equal to delta P. P2 in this case will be equal to rho G H plus X. So this is minus, we have rho G capital H times A. Now we can simplify this. We can say this is rho G H plus we have rho G X, we have minus rho G H, and this is multiplied by A. We can cancel rho GH with rho GH. So simply we left with rho, this is density of liquid, rho GX times A. So if we rearrange this one, this will be equal to rho L X A times G. So the answer is this one. So you need to understand, often we understand that P, pressure due to liquid, is equal to rho GH. But this rho is the density of fluid. So you have to be very clear about this one. So in this formula, P is equal to rho GH, and in this formula, rho is density of liquid. So this is the point they are testing. They are trying to check your understanding of this. So is this density of liquid, or this is density of object itself? This is density of liquid. That's the reason we have written here rho L. So this is density of liquid. Density of liquid. Let me emphasize on this formula again. P is equal to rho GH. This rho is density of liquid. So we can say this is density of liquid, or simply you can say this is density of fluid. And this H, this is the depth. So you need to understand this is depth. And P is the pressure. So this is. So you have to be very clear about this one. What is this rho? This is density of fluid. For question number 16, it is given to us a ball drops on a horizontal surface and bounces elastically. Elastically simply means that there is no change in kinetic energy before collision and after. Means kinetic energy of the ball before collision is equal to kinetic energy of the ball after colliding with the surface. So simply in this case, we can also write down kinetic energy initial is equal to kinetic energy final. Kinetic energy before collision is equal to kinetic energy after collision. But question is asking us what happens to the kinetic energy of the ball during very short time that it is in contact with the surface. So when the ball is in contact with the surface, speed of the ball is zero. Speed of the ball is zero means ball has no speed. As the speed of the ball is zero, it simply means that kinetic energy of the ball is also zero. Now we need to find out what actually is happening. Imagine that we have a ball, and this ball drop from certain height. It will hit this ground. It will hit the surface. When the ball will hit the surface, you can imagine that, let's say this is the ball. This, my hand, upper hand is a ball and the lower hand is the surface. So ball is coming down like this. When it will touch the surface, ball will expand. Mean the shape of the ball will change. So ball will deform. And then this ball will gain shape again and rise up. So ball will go down, its shape will change, it will deform because there is a force on the ball in upward direction, and then ball will gain shape again and ball will go up. So this is what is happening. So at this point the shape of the ball will change. So the shape of the ball will be like this. So when shape of the ball change, in this process kinetic energy of the ball that will be converted into elastic potential energy of the ball, because at this point ball is not moving. Now in this case there is a resultant force on the ball. So finally this ball will change direction and it will rise to the same height. So kinetic energy before collision and after will be the same, but kinetic energy when it is in contact with the surface will be zero. So in this case kinetic energy will be converted into elastic potential energy of the ball. So this is the point you need to understand. Now let's try to find out the best possible option. Most of the kinetic energy is lost. No, this is wrong. This is elastic collision to heat and sound. This one is wrong. The kinetic energy decreases to zero and then returns to its original value. First of all, kinetic energy will be converted into elastic potential energy, then again this will be converted back into kinetic energy. So B is possible option. Kinetic energy remains constant because it is an elastic collision. This one is wrong. We are talking about when the ball is in contact. So that time ball is not moving. Option D, kinetic energy remains constant in magnitude but changes direction. This is wrong. Kinetic energy is a scalar quantity. It has no direction. So this option is also wrong. So the option A is also wrong. So the best possible answer for this question is B. Tricky question, but very important to have better understanding about kinetic energy and elastic potential. Very nice question on this topic. For question number 17, it is given to us some gas in a cylinder is supplied with thermal energy Q. Supplied means this is the input energy. The gas does useful work in expanding at constant pressure from volume V0 to volume Vf as shown in figure. We need to calculate efficiency of this process. So efficiency simply is equal to useful energy output, we can say useful energy output divided by total input energy. In this case, useful energy out is the work done by gas. Useful work done by gas. So we can say W by gas divided by thermal energy. So we can say thermal energy. This is the energy input divided by thermal energy. And thermal energy in this case is given is equal to Q. So we can write down thermal energy is equal to Q. Work done by gas is equal to T times delta V. Work done by gas. So we can write down this one. T times V final minus. This is the change in volume. Gas is expanding. So the V final is greater. V final minus V initial divided by energy supplied means thermal energy. So the answer for this question is C. Very straightforward question. Simply you need to understand work done by gas. For question number 18, it is given to us an object of mass 0.3 kg is thrown vertically upwards from ground with an initial velocity of 8.0 meters per second. The object reaches a maximum height of 1.9 meters. We need to find out how much work is done against a resistance as the object rises to its maximum height. So this question is simply about conservation of energy. Means the initial energy has to be equal to final energy. Conservation of energy. Now if you look at this object, initially this object has speed that is equal to 8.0 meters per second and object object will reach its maximum height. At this point, speed of the object will be 0. So when this object is moving up, object is gaining gravitational potential energy and object is losing kinetic energy, and object is also doing work against friction. So simply we can say the change in kinetic energy of the object, or we can say kinetic energy lost, that will be equal to change in GPE, means the gain in GPE, plus we can say work done against friction. So simply conservation of energy. Now in this case, change in kinetic energy is simply equal to 1/2 mv square. In this case, change in kinetic energy is equal to 1/2 mv square, and this one has to be equal to mg delta h plus work done against friction. This is what we need to find out. We can rearrange this one. We can say work done against friction is equal to 1/2 mv square minus mg delta h. Now simply we need to plug in values. 1/2 mv square, mass of object is given 0.3 times v, value of v is given is 8, minus we have mgh, m is 0.3, g is 9.81, and height, maximum height is given, that is 1.9. So if we calculate this value, our answer will be 9.6, and if we solve this one, our answer will be 5.6. We need to find the difference between these two. Difference will be equal to 4.02. So this is our final answer, work done against friction. So this is our final answer. But if you look at this question, there is something quite tricky about this question. You can see we have 9.6 here, and in given options you also have 9.6. We have 5.6 here. In given options you have also 5.6, but if you add these two together, this one is equal to 15. So this is also in options. So very tricky question. If you don't use conservation of energy, or you don't know how to answer in a right way, it's quite possible your guess will be wrong. So the answer for this question is A. For question number 19, it is given to us a water pump raises a mass of 27 times 10 to 3 kgs of water through a vertical distance of 80 meters in a time of 1 hour. We need to find out what is average useful output power of the pump. So very straightforward question. Power is equal to useful work done by pump. We can simply say useful work done by pump. Work done by pump divided by time taken. So we can say divided by time taken. Useful work done by pump in this case is equal to gain in GPE. So we can say gain in GPE. Gain in GP divided by time. Gain in GP we can write down, that is equal to mg delta h over t. In this case we have value of mass, that is equal to 27 times 10 to 3 kgs. G is equal to 9.81, and height is given, that is equal to 80 meters. And time taken is 1 hour, and 1 hour has 60 minutes and 60 seconds. Now if we simplify this one, we will get our final answer, means the value of P, that will be equal to 5.9 times 10 to 3 watts. We can write down this one in kilowatts. 5.9 times 10 to 3 watts. So you can say this is equal to 5.9 kilowatts. So the answer for this question is B. I hope these questions are clear to you. If you have any question, just leave your question in comments and I will answer as soon as possible. Bye for now and see you in next video.